So what we've got here is we're trying to construct an open top box from a sheet of 36 by 24 inch cardboard. So we're going to cut the corners out of them, fold them up. It's going to look essentially like this. And of course we'll fold up the edges. The dimensions of the box will be X for the height, 36 minus 2X for the length, and the width will be 24 minus 2X. So we plug that into the volume formula. Volume of this box is going to be 36 minus 2X times 24 minus 2X times X. We do the arithmetic, we get 4X cubed minus 120X squared plus 864X. Take the derivative of that, it becomes 12X squared minus 240X plus 864. Factor a 12 out. And there we are. Now try factoring this, but this does not factor out, so we're going to need to use the quadratic formula for this. So it's 20 plus or minus the square root of 400 minus 4 times 72. And that's going to be over just 2. Again, we don't need the 12 in here because the 12 has no effect on what makes x equal to 0. That's the reason we can factor it out and not be affected by it. All right, what is the 4 times 72 here? And then 400 minus 288 is 112?
Yeah.
And 112. 4 goes into it. Does 16 go into it? Yeah. So 16 times 7. So this becomes 20 plus or minus 4 square roots of 7 over 2, which is 10 plus or minus the square root of, no, 2 square roots of 7. All right, so do the calculations for that.
You just divided it by 16.
Huh?
No, you just divided it by 16, so it would be 4.
Yeah. It's 4 right here,
Okay.
but then I factored out a 2. Does that make sense?
Mm-hmm.
Okay. So we got 10 plus or minus 2 square roots of 7 there. So from there, what I want you to look at doing, I want you to think about which one of those would produce the maximum volume if we cut out the corner. So we've got 10 plus 2 square roots of 7, right? What is that approximately as a decimal? Let's go 2 decimal places here.
15.29.
15.29. All right, what's 10 minus 2 square roots of 7? 4.71. So which one do you think is going to produce the greatest volume?
15.
Well, that's actually wrong. And the reason is this length right here is 24, right? So we can't cut, the greatest we could cut would be 12 from each part, and if we cut 12 from each part, we'd be left with nothing. So the 15.29 would actually give us a minimum. It would give us a negative volume if we did it mathematically. But the 4.71 is the value that will give us the greatest volume. Because think about it. When it's 4.71, you're not taking much from the base and you're not taking much from the length. You're just not increasing the height by much, but that's only one dimension when it comes to it. So 4.71 is going to be our approximate height. So what would be the dimensions? The length would be 36 minus 2 times 4.71. the width would be 24 minus 2 times 4.71, and the height would be 4.71. So someone do that arithmetic in your head real quick.
Hey, question mark.
Yes.
I should ask this while ago. Why did we take the derivative?
Because to find a maximum or a minimum value, we need the derivative either set equal to 0, undefined, or it needs to be an endpoint. So, is there a question about this now? With the optimization problems, do you not have that in your notes? Optimization to find an extreme value or maximum or minimum value. You set the derivative equal to 0, derivative is undefined or an endpoint. Well, the only endpoint would be is if you let x equal 0 here, but what's wrong with letting x equal 0? You don't have a volume, you just got a flat piece of board, right? Or the other endpoint would be if you let x equal to 12. But if you have x equal to 12, you just got everything cut away. So you've again got a volume of 0. So that value would be what we would be looking at as the solution. Now, any other, what did we get as the length here?
27.58.
27.58, and the width?
I think it's 26.58.
Yeah, it would be 26.58.
And 14.58.
14.58. All right. Because that would be a little bit greater than 9, and 36 minus 9 would be 27. So it would be, yeah, it'd need to be 26.58 instead of 27. All right. Any other question here? So if we wanted the volume, we would just multiply that times that times that, and it would come up with the volume there. All right, in your calculator, what I want you to do is I want you to graph this equation right here. And those of you who are viewing this video at home, do the same thing. And this is 864 here. And if you would rather, yeah, that's good enough. You're probably gonna have to adjust your window a good bit.
Which one? Do you have a calculator charger?
What end is it?
That's not like it.
How do I see it?
4x cubed minus 120x squared plus 164x.
So, essentially when you graph it, here's 0, here's 12. So it does something along the lines of this, right? It's a cubic. So the graph, huh?
Mine is not. Stop loading.
Oh,
I think it for the Yep, I
Yep.
cannot exit. What?
Fine. Hotel California, you can check out anytime you want, but you can never leave.
I'm gonna see if it loads now. I turned it off and back on.
That's what I got. Same thing even now.
I don't know why it gives different stuff.
Hmm.
Oh, Ethan. Oh, no.
Send me through an equation for your governor. Yes.
Ethan, we took the exact same equation and we got different jobs.
Maybe we have it in a
That's
different
not
mode.
good.
You have yours in degree.
Doesn't matter.
It doesn't have any.
There are any trig functions in it, so
I don't know.
Retreat for the rep experts.
Yeah.
Yeah,
Yeah.
but the rates.
It's just mine's in
Which is where y'all
thousands
get-
and his is in 12. So
Huh, well, you could.
so what is the volume?
My question is straight.
Someone do that arithmetic. 26 point.
1,825.296.
Okay.
It's not
So
that.
I need
Zoom not
to, I need to go to 1200 then probably.
you could do Zoom 0 and if
What
it's
does
a,
it look like, Rob?
That works. Same zero.
yeah,
Mine is very slow.
relatively.
Oh, we all get
Whoa.
It's hard to tell
stuff.
what scale this is on.
She got something different.
I'd be
I mean, the shape's the right way, so.
Oh, it said to zoom up to 500,000. I do. It took me up to 500,000.
Huh.
Alright. I don't think that's my calculator. It's a little temperamental sometimes. He said 500,000.
Yes.
Oh yeah, you know it's good when everybody gets a different answer, typing in the same thing.
That's not ideal.
Okay, so James is the only one that works.
It's shaped.
No, it's shaped the same, but it's just the degree of the spaces on the y-axis. Ours are way closer together than Jim's are. We can't show the difference between 10,000 and 100.